welcome. In this session, we are going to study the projections of a straight line. A straight line is a one-dimensional element connecting two points by the shortest distance, and the length is always a true length TL. The projection of a line can be obtained by drawing the projections of its endpoints on different planes. So, let's start. A straight line AB is perpendicular to HP and parallel to VP, where the point A is H units above HP and point B is D units in front of VP. Observe the front view of line AB as line A', B'. As you can see from top, point B is visible and it hides point A. So, projectors from point B passing through A meets HP at point BA, which is the top view. So, let's see how it will appear on paper. For this, first draw a horizontal reference line XY. Then draw a line A', B' above and perpendicular to XY with endpoint A' at a distance of H units from XY. Next, mark a point BA below XY at a distance of D units in line with line A', B'. Line A', B' and point BA are the projections of the line AB on VP and HP respectively. Now let us take another case. A line AB is inclined to HP at an angle theta and parallel to VP at a distance of D units. Point A is H1 units above HP, while the point B is H2 units above HP. Well, look at the diagram carefully. The projection of line AB onto VP and HP is line A', B' as the front view and line AB as the top view respectively. Alright, now we'll perform the steps for drawing these projections on the paper. Draw horizontal line XY as a reference line. Then locate point A' at a distance of H1 units above line XY. From point A', making an angle theta with HP, draw a line of length equal to AB. Locate the other point B'. So, line A', B' will be the front view of line AB. Now, change the position of the observer. Looking from the top view, the projectors are passing through A and B and meet the HP orthogonally at points A and B. The line AB is the top view of line AB. The length AB is the shortened length of line AB. Easy, right?
Let us understand the term projection of a line. A line AB may be situated in space in any of the four quadrants. Consider line AB is situated in first quadrant. The position is obtained by extending the projectors onto the planes. Now, opening the horizontal plane or rotating the plane in clockwise direction, we get the following result. Let us see positions of a line with respect to HP and VP. A line may occupy infinite number of positions in space with respect to HP and VP. The various positions may be classified into the following types: perpendicular to one plane and parallel to the other, parallel to both HP and VP, inclined to HP and parallel to VP, inclined to VP and parallel to HP, and line inclined to both HP and VP. Let's see a line perpendicular to one plane and parallel to other. In this, a line can be perpendicular to HP and parallel to VP, and perpendicular to VP and parallel to HP. For the first case, the representation of a line is as shown, and its orthographic pattern is also shown. In this case, front view is vertical line, which is true length, and top view is a point. For the second case, the representation of a line is as shown, and its orthographic pattern is also shown. In this case, front view is a point, and top view is a vertical line, which is true length. Let's see a line which is parallel to both HP and VP. For this case, line AB is parallel to both HP and VP as shown, and its orthographic pattern is also shown. In this case, front view and top view both are parallel to the line XY, and both show true length AB. Let's see a line which is inclined to HP and parallel to VP. For this case, line AB is inclined with respect to HP, but it is parallel to VP, and its representation is as shown, and also its orthographic pattern is shown. In this case, front view is inclined to line XY and shows true length of AB, and top view is parallel to line XY. Let's see a line which is inclined to VP and parallel to HP. For this case, line AB is inclined with respect to VP, but it is parallel to HP, and its representation is as shown, and also its orthographic pattern is shown. In this case, top view is inclined to line XY and shows true length of AB, and front view is parallel to line XY.
Line perpendicular to HP. In this, we will see about how the projections will look when a line is perpendicular to horizontal plane. The top view is a point and the front view is a line showing the true length of the straight line. When a line is parallel to VP, its front view will show the true length. Line perpendicular to VP. In this, we will see how the projections of a line will look when it is perpendicular to VP. The front view is a point and the top view is a line showing the true length of the straight line. When a line is parallel to HP, its top view will show the true length. Line parallel to both HP and VP. In this, we will see how the projections of a line will be when it is parallel to both HP and VP. Both front view and top view will be parallel to XY and both will show the true length of the line. Line parallel to VP and inclined to HP. In this, we will see how the projections of a line will be when it is parallel to VP and inclined to HP. The front view will show the true length and the true inclination of the line with HP, theta. The top view will be parallel to XY and show the reduced length. Line parallel to HP and inclined to VP. In this, we will see how the projections of a line when it is parallel to HP and inclined to VP. The top view will show the true length and the true inclination of the line with the VP, phi. The front view will be parallel to XY and show reduced length. Line contained by VP. In this, we will see how the projections of a line will be when it is contained by VP. The top view of the line will lie on XY line. The front view will show the true length. Line contained by HP. In this we will see how the projections of a line when it is contained by HP. In this, the front view will lie on XY line and the top view will show true length. Line contained by both HP and VP. In this, we will see how the projections of a line will be when it is contained by both HP and VP. In this, both front view and top view will lie on XY line.
Today we will discuss about projections of lines when the line is parallel to both HP and VP. Draw the projections of a 75 mm long straight line. The line is parallel to both HP and VP and 25 mm from each. That means 25 mm from the HP, 25 from the VP. The line is like this. This is horizontal plane and this is the vertical plane and this is the XY line. The intersection of the two planes. Here the line AB parallel to HP and VP. Line is like this. Parallel to HP and parallel to VP. We have to draw the front view. This is the front view direction and you get the front view on the vertical plane like this. This is the front view direction and you get the front view like this. Front view indicated by A dash B dash. A dash and B dash line indicate the front view of line AB. Similarly, you have to draw the top view. You have to see top view from this direction like this. And this is the top view direction. You get the top view on the horizontal plane like this. Top view indicated by line AB. This is the top view and this is the front view. And this distance is the from HP 25 mm. The line is above the 25 mm. From this line to the horizontal plane is 25. From this line to the vertical plane is 25 mm. The line length is 25 mm. The line is like this. But you have now we have to draw the orthographic projection. That is, you have to draw the front view and the top view. See the pictorial projection. Now we have to draw the orthographic projections. Here the front view and top view both are parallel to XY. This front view line and top view line both are parallel to XY line. Both indicate the true length. This front view length also 75 mm. The top view length also 75 mm. That is equal to the length of the line. First you draw the XY line here. And you draw a projection line like this. Now on this line you have to draw the projections of A. Now first we draw this point. From A dash to the XY line is the 25 mm. Like this is. From A dash to the XY line is 25 mm. First you draw the A dash at a distance of 25 mm. Now A dash to the B dash is the 75 mm. This length is 75 mm. Parallel to the XY. Like this. Now we have to indicate the A. From XY to the A also 25 mm. We have to indicate the A. A means top view of point A. Like this. Now A to the B is 75 mm. Now join the B dash B also. This A dash B dash is the front view of line AB. This AB is the top view of line AB. Here the line is parallel to both HP and VP. That's why we are getting the true length in the front view, true length in the top view.
Hi guys, Manas here, and today we're going to be discussing projection of line. So it's going to be level 1 where we're going to see line inclined to one plane. It could either be inclined to HP or VP. Alright, so here is problem number 1 and it goes like this. A line 50 mm long is inclined at 45 degrees to the VP and parallel to the HP. Alright, the nearest end of the line is 25 mm in front of the VP. Draw the projections of the line and if it is 40 mm above the HP. Alright, so I've made a pictorial representation of this particular description where you can see that this line over here is inclined at an angle of 45 degrees to the vertical plane, and this is the true length of the line. Alright, and this particular true length can only be seen from the top since it is inclined to the VP. Okay, now one more thing which has been given in the question is that the nearest end of the line, nearest end to the vertical plane, that is NA, is the nearest end. Alright, and NB is the farthest end. So this nearest end to the vertical plane lies at a distance of 25 mm from it. Okay, so we're gonna write here that is DA, the nearest end, is equal to 25 millimeters, and true length obviously is 50 millimeters, and the angle that the line makes with the vertical plane has been given as 45 degrees. At the same time, it's being said that the line is parallel to the HP. Now if it is parallel to HP, now guys remember, if a line is parallel to HP, then each and every point on this line will be at the same height, and that same height has been given as 40 millimeters. All right, so here it is. I'll show you if it is 40 mm above the HP. Okay, so line parallel to and 40 mm above HP means that all the points constituting that line are 40 mm above HP. That's it. So that's the conclusion we can derive. And now let's get on with the question. Okay, so when you rotate this, you have a projection something like this. So H is going to be above, D is going to be below, since it is a projection supposed to be made in the first quadrant. All right, front view, top view, this is going to be vertical plane, and this over here is going to be horizontal plane. You can see this. Okay, so when you rotate this horizontal plane by an angle of 90 degrees, you're gonna have a horizontal line. This horizontal line, you're gonna have this, and below which you're gonna have a horizontal plane, and above this you will have this vertical plane. Okay, now guys, as far as projection of point, line, solid, or anything, you always need to figure out as to from which view you have to start the problem. Now since it is a line, the true length of the line can only be seen from the top. The true length of the line can only be seen from the top, so hence we have to begin by drawing the top view first. All right, so I've written down all these data. So HA and DA has been given to us. H is going to be above XY, 40 above, 25 below. So let's draw this. 40 above and 25 below, and this point over here is point A dash, and this over here is point A, simply A. Now the true length of the line can only be seen from the top, and it is going to be seen as if it is making an angle of 45 degrees with the vertical plane. All right, so we're going to do this inclination, and the true length has been given to us as 50 millimeters, and this angle is going to be 45 degrees. So that's it. So this is exactly how the line appears from the top. Okay, so this over here is going to be point B, simply point B, and then finally we have, if you look at this object from the front, it would appear as a straight line. This line is going to be absolutely parallel to this horizontal line. Okay, this line is going to be absolutely parallel to this horizontal or the reference line. So what I'll do is, I'm gonna draw a line over from here randomly of any suitable length, and then finally I'm going to look at this from the front, and from the front when I look at it, it's going to end up somewhere here. So this over here is going to be my final front view. So this is going to be B dash. Let me chop off this portion with respect to this line. Okay, and finally we have this as the front view and this as the top view. Let me darken both of them, and it should finally look something like this. All right, so guys, one more dimension that we can actually do is this over here. This is going to be 50 millimeters. Now one more thing which you can do is this. Okay, so the angle which has been given to us is this has been given to us as 45 degrees. Well, that's it. That's how you prepare the drawing for a line which is inclined to the vertical plane. Okay, and it is parallel to the horizontal plane.